Hi, I'm Debbie Nelson with Nixene Publishing. I am a contributing editor and project manager here in the United States. And we've been doing a series on graphene with Adrian Nixon, our editor-in-chief, who is in Yorkshire, England. Good morning, Adrian. How are you?
Good morning, Debbie. I'm very well, thank you very much. Well, it's afternoon here, morning
Uh,
for you.
true. We have that time gap. Well, today we have in our graphene studies, we've got a mystery. So I wonder if you would share with us this mystery about graphene and copper.
Yeah, this started probably last year when I was looking at the Geek, the Graphene Engineering Innovation Centre. So we've covered that in previous videos, Debbie, haven't we?
Yes.
So Rob and I go in there on a weekly basis. Well, when it's open, when we're not all locked down. And the Geek has a demonstration table with lots of samples of different types of graphene, one of which is CVD graphene, if you remember the bottom-up graphene that we talked about that grows on copper foil. And I was having a chat with some of the scientists there because there's two samples of graphene and they're different colors. And it got me thinking. And I got talking to the one of the scientists there, and he said, "Oh yeah, there's a big mystery going on about corrosion in copper. So can I show you my? I'll share my screen, and you can see what I mean. So let's have a look at this mystery. Bear with me a second. Click on that and share, and I'll just minimise our videos again, Debbie, so that we don't interfere with things too much. Should be a white screen there at the minute. Is that what you've got?
We do.
Good. So this is a picture I took last year in August, and can you see here that there's two petri dishes, each has a copper foil sample in. These are probably about 7 centimeters by 7 centimeters, that sort of size, to give you an idea of the scale. And they're on the demonstration table at the Geek, and this is the one on the left here. This is blank copper foil with no graphene on it. But can you see over here, this one with graphene on it is a slightly different color.
Right.
Hmm, it's a mystery why that color change has happened. Now, what seems to be going on is when we looked at the color of the copper and done some research, and by the way, on these slides, whenever I put a slide up that has some references, you'll always see my references at the bottom of the screen. So people can either actually, they can't click on this from the video, can they, Debbie? But I'm sure we can make the references available on demand if people ask.
Yes, we actually could pop those down in the comments, so I can take care of that. Yeah.
Okay,
Yeah.
great, thanks.
Make that
So
available.
we can see here that the darker copper foil sheet has gone darker and redder, and that's due to what looks like to be copper oxide that's formed under the surface. Now, this oxide means that some corrosion has been happening on copper. Yet everybody knows that graphene is supposed to protect copper from corrosion. And yet now what we're seeing is the graphene coating seems to accelerate the corrosion of copper because these two foil samples were both around about the same time, and the graphene was coated onto one sample, and then the other sample was kept. So they're the same age, and yet the copper with the graphene on was corroded more than the one without. So that seems to indicate that the graphene is helping the copper corrode, which is exactly the opposite of what we expect. So it's a bit of a mystery, isn't it?
Yeah, it definitely is.
Hmm. So what I did was this got me thinking a little bit further, and then in December we were looking at another sample of copper foil. This is about the same size as the other ones, and what we see here is, can you see along the side here, Debbie? We've got like a line going down this piece of copper foil.
Right.
And on this narrow strip here, this is the uncoated copper at the edge. But can you see the rest of the copper foil here is like a lighter silvery color?
Right.
Now, what we've got, it's important here to see that lighter silvery color. So that sample there and this sample here should be the same, more or less. They're both copper foil. They're both coated with one atom thick layer of graphene, yet one is darker and the other one's lighter. Now, the main difference is this sample here is fresh. So it was only made a few weeks before we saw it. And the CVD graphene coating on the surface of the copper foil is protecting it. So it seems to be uncorroded and lighter and brighter. Yet over time, the graphene seems to be causing the copper to corrode. It's a bit of a mystery, isn't it?
Yeah, it really is. It's what's making the difference between the two.
Yeah. Now, that would have remained a mystery until a month or two ago when I saw a piece of research that seems to have unlocked the problem. So we now know what's going on. So let's have a look at this. There's a new study here that seems to have settled the debate. Now, I've deliberately put these slides on reveal, so this will build some information for you because there's a little bit to get your head around. So I didn't want to give it you all at once. So this is what's called time evolution studies of graphene grown on copper substrates. So basically, it's looking at what happens to copper in the presence of oxygen when it's got graphene on top of it. Now, if we're starting off, we're looking, if we cover the copper foil with what's called single crystal graphene, that is perfect graphene with no holes, no gaps, and it's that one atom thick layer continuously across the surface. Now, that will never ever corrode. It's a perfect barrier. However, that's not what the current crop of CVD machines, the chemical vapor deposition machines, create. What they create is something called polycrystalline graphene. And we've talked about this in previous videos, Debbie, but do you think that's clear enough for the audience at the minute?
I think so, because when we talked about it before, we talked about having the gaps and not in an imperfect sample of graphene on the CVD, right?
Excellent. And this next graphic here will show you what those gaps will look like. So you're quite right, Debbie. Polycrystalline graphene has these little gaps and cracks in it. And that's what's actually on the surface. So you remember that both those copper samples I showed you before, you can't see it with the naked eye, but down at the microscopic level, this is what the surface looks like. It's not as regular as this. It's a bit like crazy paving. There's holes and gaps. And the thing is, these grain boundaries let in oxygen. So this black dotted layer here represents the polycrystalline graphene, and the orange block here represents the copper foil. And with me so far?
Yeah, absolutely.
Great. So when copper coated with polycrystalline graphene copper is coated with polycrystalline graphene, it lets in oxygen. Now, uncoated copper seems to corrode less in the short term. So there's something odd going on here. What actually seems to be happening is this is why the sample that we saw previously had gone red. The oxygen is getting in through these cracks, and the graphene seems to be catalyzing, which means it accelerates the corrosion of the copper and forming this reddish copper oxide layer between that one atom thick piece of graphene and the copper foil. And because the graphene is transparent, you can see through it to this reddish layer that's growing underneath. And so the uncoated copper hasn't corroded yet. Yeah, that all right?
Yes, especially the transparent part.
Yeah, it's important that graphene is transparent. So what's going on here is that in the short term, graphene is acting as a catalyst and getting this copper oxide layer to form more rapidly. Now, what the study found was that over the longer term, and they looked at this over a year, once you've got this copper oxide layer forming underneath the graphene, that acted like a barrier to further oxygen. No more oxygen could get in and get past that initial oxide layer, and it stopped any further corrosion. Whereas unprotected copper actually did corrode more deeply and just kept on corroding and corroding and corroding, and it would have just carried on and carried on until the copper was all gone. So this sort of unpacks the mystery, which is, yes, copper does corrode initially with polycrystalline graphene on the surface, but once that corrosion has formed, it forms a barrier and stops the corrosion forevermore, and then unprotected copper will actually carry on corroding. Do you think that sort of explains and solves the mystery, Debbie?
Well, it sounds like it to me, because if copper was supposed to protect graphene, I mean, graphene was opposite. Graphene's supposed to protect copper, then it does, but only if it's single crystal graphene, or it does provide a thin layer of the copper oxide and then protects it from there, from that point.
Yes, exactly. And the important point, I'll stop sharing now, we can get back to seeing one another. So the important point is that we just need to be aware that the graphene that's grown on copper foil at the moment by the CVD process is polycrystalline. Very few people will tell the average person that, so you don't realize that's what's going on. And these little gaps and cracks are what let the oxygen through. But when we eventually get to make single crystal graphene, then that will be a perfect barrier, and we'll get perfect protection.
Very interesting. Kind of makes you wonder what you do with the copper that has the little thin layer of of the copper oxide on it,
Yeah, that's a good
protected
point.
with
Could we
graphite.
find a use for it? The honest answer is I don't know the answer to that question. Maybe you could make decorative panels or roofing or something like that out of it. If you value a nice reddish colour. For the
Yeah,
moment, maybe that's another mystery you've surfaced, Debbie. We'll have to look into that.
absolutely. Maybe our viewers will leave their comments.
Yes. So we better stop there. But if anybody watching the video has got any ideas about how to use this graphene with a little bit of oxidation underneath the surface, get in contact with us, and yeah, we'll see if we can point you in the direction of the researchers who are working in this area.
Absolutely. Again, thank you so much for your time, Adrian. This was fascinating, and we'll be back again with more about graphene.
Pleasure.